Hello, I'm JW. Now, in a previous video, I had a look at some of those Wago connectors and the fake ones, which were rather similar. And one of the comments there actually mentioned these things. These are little white connectors with the spring-loaded things on the top. And I've seen these in various places. These actually came from eBay and a whole bag of them. I've also seen them on certain cheap light fittings as well. So we're going to have a look at these and also test those as well. And another thing which was mentioned in the comments there were these despicable, what used to be called Scotch lock connectors. Now these are normally used for car type wiring, or at least they were until people found that they were a big pile of junk and shouldn't be used. So essentially it's a method where if you've got a wire, you can shove this over the wire, put a second wire in and then just gouge the top thing down, and it allegedly makes a connection between them without having to cut into the existing wiring. So we've got a few of those as well. We'll have a look at those also. So I've got these wire connectors. I say someone in the comments of the other connector video suggested these. Now these came from someone on eBay, but you can get them from loads of different places. It's the same kind of deal as most of this other Chinese type of stuff. And all we got here, these are just pairs. So it's just straight through connection on each side. Little buttons on the top just formed out of the plastic. And again, the idea here is you just press down the thing, it opens a little gap in there where you shove in the wire, and then when you release it, the spring clamps the wire into position. And this side, of course, is the same. This side is sort of fully open there, and look on the back here, it's got this sort of extra piece at the bottom, and this is presumably because when these are assembled, the plastic, of course, is molded first and the metal is inserted afterwards, so it's presumably the metal is just shoved in from this end with this piece here acting as a stop, so it doesn't have to go all the way through and out the other side. And then once in there, it's basically held in place by the spring pressure against the two pieces on the top here. So yes, it's just to sort of take your wire, shove it in the end there, and just take a bit of wire here. One of these 12-watt light connectors. So it would simply be press that down, shove the wire into the hole, and then that grips onto it thusly. And yeah, there is a significant amount of grip on that, and again, we're pulling it out, it's actually breaking the wire rather than particularly busting the connector, though it has bent it up somewhat there. And again, the other end's going to be the same, it's just got a slightly wider opening because of the way the plastic moulding is constructed. So they certainly seem to grip the wires decently well. The only problem with these, I think someone did also point out in the comments, is that if you put these in a light fitting, say it was on the ceiling or something, put your wires in, and then of course when it's closed up, it's certainly not impossible something just to press down on this, and of course once that's happened, these can just fall out. So a bit of a disadvantage there. If these are going to have any pressure put on them, that will basically release the thing completely. And you see that one now has actually broken. I've just pressed it there, probably because I wrenched the wire out of it. Yeah, it's actually bent the metal piece too far forward, but obviously that was on wrenching the wire out. So we'll get rid of that one. Now the rest of these, we'll see what sort of current these can actually take. So of course we'll do that outside in a similar way to the other ones we tested before. Now these actually were a bag of 30, I think these were only about $1 or something like that, so again incredibly cheap, and that was also including delivery from China or Hong Kong or somewhere. So very, very cheap items, but that's not necessarily a good thing. Now the other thing which was mentioned are these despicable things. Now these used to be called Scotch lock connectors from the manufacturer that originally made them many decades ago, and these were mainly sold for automotive use, as in your car or something. Now the way these are supposed to work, and whether these work is another story, we'll try them later, but basically you've got one of these pathways that goes all the way through, and the other one has a sort of a crude stop moulded in. So the idea was you've got a wire in your car, for example, that obviously you don't want to cut into, but you want to take the power from. So your wire would shove in the side, see that will open up there to allow things to be slotted in the side like that. So that would be your basically your existing wire in your car. And then the wire you want to attach, you would just thread into the end here. So we can just use this other screwdriver as an example. That would go in like that. And then you take a big pair of pliers and mash this metal thing down, and that will go through and pierce the insulation of both wires, and therefore make a connection over to the other one, and then you would connect that across to whatever device you were attaching in your vehicle. and then this plastic lid would basically clip over the top to basically insulate that part, which is obviously would be flat, and then clip right there to prevent the other wire from obviously pulling out of the side. So supposed to be a cheap and easy way of doing these things, but the problem is that this may well pierce down into the wire, but any bit of moisture gets in, it's going to start corroding this away. That's why they're not really recommended for use in any kind of application, and these were really never designed for mains voltage use either, so clearly unsuitable for that. And the other thing, they only work with stranded wire because the thing had to basically pierce down either side, so obviously at a solid core it's not going to fit in that little tiny slot there, otherwise it's going to basically just slice through the whole conductor. But nevertheless, we'll see what kind of current these can take. I've got a few of them here. Again, these were very cheap things, only a few pennies each. Now, for this test, we've got the connectors and some fairly thin wire here. This is 0.75mm copper, mainly because it's basically what only fits into these things. That's about the maximum you're going to get into those red things, and these white things don't have much capacity either. So essentially, we've got the first connector here. We've actually just looped through. So we've got the current going through both halves, may obviously heat up more than on the single. Then we have one of these dreadful red things, and this one actually goes through here, and then we connect on that one, so that's effectively connecting one wire to another. Then we have the white one and just straight through in that case, not using the other side. And then finally we've got this one here, which is the same piece of wire, hasn't actually been broken. We just clamped it over the top, because of course clamping over does actually damage the conductor inside on the existing cable there. So that's what we've got. Two ends there, of course. We're going to connect the power supply, and we're just going to turn up the power until something melts. So here's the kind of setup here. Got the current on the clamp meter at the top left, and the time elapsed in that thing in the middle, which is already counting away. And just got the two wires going in, and the thing just laid carelessly on the side. So let's turn on the power and see what gives. So it's turning up the current there from its sort of initial state, and stick about 5 amps there or so. I mean, that's a fairly small amount of current. It's certainly well within the capability of the wiring we've got. So let's just see if anything happens there. One would hope not, because these are, I say, 5 amps is basically nothing at all. Okay, well 5 amps doesn't seem to do a lot, so let's just turn it to about 10 amps and then see what we've got there. So just under the 10 amp mark there. And in fact we can already see that the connector at the foreground there is actually moving, and it actually appears to be melting through the side of the connector. Bearing in mind current's only around the 9 amps mark here, and we can see it's now smoking and smouldering, and the other one at the back is also starting to smoke as well. Still only around 10 amps there, so nothing excessive, and so they're both now smoking away considerably. Wire piece has actually come completely out of the first connector. A lot of smoke now pouring off, and they're now both smoking considerably. As usual, it's fairly windy, so the smoke is blowing away quite readily. But that's a huge fail on both of those. And so bearing in mind we're only still at that 10 amps level, which is basically pretty much nothing at all. And we'll see there, it's now gone open circuit. Hardly surprising, given that the actual connector pieces have basically just melted right out of the plastic housing. And the current there would say only around 10 or a maximum of 11 amps there, so nothing excessive, or not even enough to blow any kind of circuit breaker or even a fuse. And we see there that the wire has come completely detached from it. The connector is just a gungy, disgusting mess with sort of strings of melted plastic coming off there. That one is sort of kind of attached, but only because the plastic is actually melted onto the copper wire. The actual connector is stuck to the piece of wood as a background, so no good there. And here's a closer look, and we can see basically it's just a bit of metal and what's left of the molten connector. Now this is the red connectors, and basically just twisted the wires together where the white connectors used to be, and we're going to turn up the current and see what gives with these, and starting at about 11 or 10 amps or something. Bearing in mind these didn't appear to do anything at that level, so I think we'll turn up the current to a more sensible level and see if anything actually fails. So increased there to about 15 amps. Again, not a lot visually happening there, but again, as you really would expect, because they didn't even move in the last one. Now I've actually turned the current up here to 30 amps, and that's actually the maximum that this setup can actually provide without destroying itself. And these wires are not actually rated to 30 amps either, they're only 0.75 square millimeters, so this is grossly in excess of the rating of the wiring. But nevertheless, we'll leave it on for a while and see actually what happens. Now this has been on for around 6 minutes at that high current, so we'll just turn that off because pretty much nothing is actually happening here. Despite it being 30 amps through there, nothing has melted, smoked, or even suggested there was a problem. I'm actually just moving the wire there with that bit of brush handle. The wires are certainly very flexible, and the insulation has been considerably overheated. It will deform quite easily when it's pressed there. But the actual connectors themselves are still just as solid as they ever were. No signs of overheating or anything else. So it seems that these things, as we see a closer view here, can easily take 30 amps plus, with no damage whatsoever visible. And so it seems fairly likely the wire would actually melt first before the actual connectors will. So these white things are totally useless and hopeless, and the main problem is, if you see here, as the thing is pressed down, the wire actually clamps between the metal and the piece of plastic above, and of course it's a very thin edge on that, so it's going to be a high resistance point anyhow, and of course any slight heating means the plastic deforms and the connection actually gets worse and looser, and of course the hotter it gets the worse it becomes, and the end result of course is the thing just melts to pieces at around 10 amps. So definitely not recommended for use on any kind of circuit. Clearly these are a pile of junk. Now that's it for this video, so until next time, thanks for watching.